Hello everyone, welcome to Automation Community. Today in this video, we are going to discuss an example in which we will use normally open contacts. We will be also implementing latching. So let's start. Example 11. If switch 1 is on, then motor 1 and motor 2 will be on. If switch 1 is off, then motor 1 will be off and motor 2 will be on. If switch 2 is on, then motor 2 will be off, motor 3 and motor 4 will be on. If switch 2 is off, then motor 3 will be off and motor 4 will be on. So for switch 1 and switch 2, we will use normally open contact, and for motor 1 and motor 2, switch 1 should be on. And then when we turn off switch 1, motor 1 will be off but motor 2 remains on. For that, we will implement latching for motor 2. We will latch motor 2. Similarly, for motor 2 to be off, switch 1 should be on. So we will use switch 2 as normally close contact for motor 2 to be off. And then for motor 3 and motor 4, switch 2 should be on. Switch 2 will be used as normally open contact. And then when switch 2 is turned off, motor 3 turns off but motor 4 remains on. For that, we will latch motor 4. So let's move to TI portal where we will draw ladder diagram and also implement latching. This is the interface of TI portal. Let's go to PLC tags first, then default tag table. So we have to add here our inputs and outputs. So we have two inputs, switch 1 and switch 2. I will write switch 1 and then we have switch 2. I will drag it to here like this. Then we have 4 motors. Let's write motor 1. I will change the address to Q0.0 as it is an output. It will start with Q0.0. We have motor 2, motor 3 and motor 4 as well. I will click here and drag it to here. So our inputs and outputs are being added to the table. So I will minimize this and then I will go to program blocks and main OP1. So here we will be drawing a ladder diagram. So firstly, I will insert a normally open contact for switch 1, and then I will insert a coil. It will be motor 1. So when switch 1 is turned on, motor 1 gets on, and when switch 1 gets off, motor 1 gets off. And then for motor 2, I will insert a normally open contact and a coil. So this normally open contact is switch 1 and then this coil is motor 2. So when switch 1 is turned on, motor 2 gets on, and when switch 1 is off, motor 2 gets off. But it shouldn't happen. When switch 1 is turned off, motor 2 should remain on. For that, we will latch motor 2 here. So I will open the branch and normally open contact and close the branch. So this normally open contact will be motor 2. So when switch 1 is turned off, motor 2 still remains on. Similarly, I will insert a normally open contact for switch 2, and then a coil for motor 3, motor 3. So when switch 2 is turned on, motor 3 gets on, and then also motor 4 should get on. So I will insert switch 2 as normally open contact and then a coil. So this coil will be for motor 4. So when switch 2 is turned on, motor 3 and motor 4 gets on, and when it is turned off, motor 3 gets on, but motor 4 should remain on. For that, we will latch motor 4 here. I will open branch and normally open contact and then close. So I will assign address to this same as of motor 4, that is Q0.3. And then when switch 2 is turned on, motor 2 should turn off. So here we will use a normally close contact for switch 2. So when switch 1 is turned on, the current will flow through it, motor 1 gets on, and also the current will flow through it. The switch 2 is a normally closed contact and false state. It will also allow current to flow through it. As a result, motor 2 gets on. So when switch 1 is turned on, motor 1 and motor 2 gets on, and when switch 1 is turned off, motor 1 turns off as it will not allow current to flow through this and motor 2 gets off. But here, as motor 2 is being placed here, the current will flow through it and motor 2 gets on. And then when switch 2 is pressed, motor 3 gets on, the current will flow through it and motor 3 gets on. Similarly, the current will flow through it, motor 4 gets on. And similarly here, when switch 2 is turned on, it will break the circuit as it is a normally closed contact. In true state, it will not allow current to flow through it. As a result, this motor 2 gets off. And also here, motor 4 and motor 3 gets on. And then when switch 2 is turned off, motor 3 gets off, the current will not flow through it, motor 3 gets off, but as motor 4 is being latched here, the current will flow through it, and as a result, when switch 2 is turned off, motor 4 still remains on. So let's start simulation here. Then start CPU, okay, then monitoring on and off, and then switch to project view. So here, let's create a new project. Let's wait for some time. And then go to simulation tables, event table 1, and then right click here and then load project tags. All the tags are being loaded here. So now we can do the simulation. So when I turn on switch 1, motor 1 and motor 2 both gets on. As the current flows through switch 1, motor 1 gets on. Here also the current flows, switch 2 is in false state, the current flows. As a result, both the motors turn on. And then when I turn it off, the current will not flow through it, motor 1 gets on, but previously motor 2 was on, the current flows through it. As a result, this motor 2 gets on. It remains on. And then when I turn on switch 2, this switch 2 in true state will not allow current to flow through it. As a result, this motor 2 gets on, and similarly, when switch 2 is turned on, motor 3 gets on, as well as this switch 2 will turn on motor 4. And then, when I turn switch 2 off, the current will not flow through it. As a result, this motor 3 gets off, but here previously motor 4 was on, the current will flow through this. As a result, motor 4 remains on. It was all about this example. Thank you for watching.